next topic is magnetic field on the axis of a circular current loop. Here we have to just consider a current carrying circular loop. Let I be the current flowing through the circular loop. R is the radius of the current carrying circular loop. Let P is a point along the axis of a current carrying circular loop at a distance x from its center. So first we have to consider a smallest element A, B. The length of the smallest element is taken as dl. The distance from the smallest element to the point B, it is taken as r. At the point P, the magnetic field intensity can be split up into two components. One is dB cos alpha and the other one is dB sin alpha. Here, this is the resultant magnetic field. So, if we consider a smallest element CD, here also the distance from the smallest element to the point B, it is R. Here also the magnetic field is split up into two components. One is dB cos alpha and another one is dB sin alpha. So magnetic field at the point P due to the smallest element dl can be written as dB is equal to mu 0 I dl sin theta by 4 pi r square. If theta is 90 degree, the value of sin 90 is taken as 1. Then we can write dB is equal to mu 0 I dl by 4 pi r square. So, if we calculate the entire magnetic field at the point B due to the current carrying loop, here the cos components can be cancelled, only the sin components are there. So that the total magnetic field at the point P is B is equal to integral dB sin alpha. Here we can write integral mu 0 I dl by 4 pi r square into, if we consider this as a right angle triangle, then we can write the value of sin alpha is equal to opposite side by hypotenuse, that is r by r. Then we can take mu 0 I r the whole divided by 4 pi r cube as constant. Inside the integral we can write dl. The value of integral dl, which is equal to 2 pi r, that is the circumference of the circular loop. Therefore, B is equal to mu 0 I r into 2 pi r the whole divided by 4 pi r cube. Here this pi and pi cancel, this 2 and 4 cancel, so that we will get this 2. Therefore, B is equal to mu 0 I r square the whole divided by 2 into r cube. So next we have to calculate the value of r. Again, if we consider this as a right angle triangle, then we can write r square is equal to r square plus x square. R can be written as root of r square plus x square, or we can write r square plus x square the whole raised to 1 by 2. So next, if we write r cube, you get r square plus x square the whole raised to 3 by 2. Therefore, the equation B can be written as mu 0 I r square the whole divided by 2 into r square plus x square the whole raised to 3 by 2. And at the same time, if the circular loop contains n number of turns means the same equation we can write B is equal to mu 0 n I r square the whole divided by 2 into r square plus x square the whole raised to 3 by 2. Suppose if you want to calculate the magnetic field at the center of the loop, then we can take the value x is equal to 0. Therefore, the magnetic field can be written as B is equal to mu 0 n I r square the whole divided by 2 into r square the whole raised to 3 by 2. This 2 and 2 cancel. We get B is equal to mu 0 n I r square the whole divided by 2 into r cube. Here r square and r cube cancel. We get B is equal to mu 0 n I by 2r. This is the magnetic field intensity at the center of the circular loop.
If you found this video helpful, please like, share and subscribe to the channel. See you in next class.